So good morning, dear students. Today we will continue discussing circles in continuation of whatever we had discussed in the last class. So today we will start with the diameter form of circle, that is a circle with the line joining the points A with coordinate x1, y1 and B with coordinate x2, y2 as diameter. So how to find the equation of this, circle? We are going to do it now. So before I proceed further, could you please confirm that you are able to view the screen properly and able to hear my voice very clearly? Can someone please let me know?
Yes, sir.
Okay, great. So if we look into the problem, so if you give a visual representation, it's something like this. You see that A with coordinate x1, y1 and B with coordinate x2, y2. These are the two endpoints of that diameter. AB is the diameter with coordinate A as x1, y1 and B as x2, y2. Now, what is our task? Our task is to find the equation, of the circle in which x1, y1 and x2, y2 are the two ends of the diameter, means coordinates of the two ends of the diameter. Now, this is a visual representation. Now, you see, dear students, there is a theorem we have learned in our earlier classes whenever we are in 8th, 9th standard or 10th standard. Okay, there we have learned that if you take any point P on that circle, suppose we took a point P on the circle, then definitely AP is perpendicular to PB, correct or not? So that we are aware of. So AP is perpendicular to BP. So that means what? That means slope of the line AP into slope of the line BP should be equal to -1, correct or not? So this implies slope of AP into slope of BP, that should be equal to -1. Slope of AP into slope of BP should be equal to -1. Now let's find what is slope of AP. Slope of AP should be y minus y1 by x minus x1, because there are 2 points. And what is the P coordinate of the point P? X comma y. And that is an arbitrary point, Why it is an arbitrary point? Because that point P will vary. As point P varies, so we will see a circle. In fact, you can see the way I'm deriving, it is also, it's finding the locus of the point P such that, AP into BP is actually always perpendicular to each other. A and B are two fixed points, and P is a variable point moving in such a manner that the AP is perpendicular to BP. Find the locus of the point P. You can view that problem in that manner also. So what is slope of AP? Slope of AP, as I was telling, y minus y1 by x minus x1. y minus y1 divided by x minus x1 into, what is the slope of BP? It is y minus y2 divided by x minus x2. y minus y2 divided by x minus x2, that is equal to -1. So from here what we get? So from here we get x minus x1 into x minus x2. So this implies x minus x1 into x minus x2 plus y minus y1 into y minus y2 is equal to 0 is the required equation of the circle joining the points x1, y1 and x2, y2 as diameter. I hope it is clear, dear students. You may say that, that I do not know whether this particular point is coming to your mind or not. That I said in my previous session that general equation of the circle is x square plus y square plus 2gx plus 2fy plus c equal to 0. So there are three parameters, f, g and c, and we need to have three information, okay, so that we can find the equation of the circle uniquely, if you recall. Then keeping this in mind, you may think, sir, here only two information is given, na? That x1 y1 and x2 y2. So with these two information, how we are able to find the equation of the circle in a unique manner? If you have this question, or I brought this question, the point here is that actually inherently there are three information given. The moment the coordinates of the the two extreme points of the diameter is given, inherently you know the coordinate of the center because it is the midpoint of AB, correct? So eventually you have three information. Anyway, so now let's proceed to the next point, dear students, and next one is that parametric equation of a circle. So next discussion, what we are going to do is that parametric equation of a circle. And let me start discussing this in a new page. So first we will consider the circle with center at origin, and then we generalize it into considering the center at any arbitrary point h, k. Okay. Now, what is the equation of a circle, with center at origin? It is, we know, x square plus y square equal to r square, where, r is the radius of the circle, correct? So, if we have, we can have a diagram something like this. First, let's consider that, let me write it down also, so that you get it very clear. For the ease of understanding, let us first so as you see in the statement, it is written, for the ease of understanding, let us first consider a circle with center at origin, and then we will generalize it to consider the case when the center is at any arbitrary point h, k. So now let's consider a circle with center at origin. What will be its visual representation? So it will be something like this. I'm just going to show you. I'm just taking it from the study material and show it to you. So it will be something like this, isn't it, dear students? Okay. That where you see the center is at the circle, which center is at the origin and having r as the radius. O is the center, and P you take an arbitrary point on that circle, then OP is equal to r. That is the radius, correct? Now, what we are going to find, dear students, is that we know that equation of this circle. What is this equation of this circle? Is x square plus y square is equal to r square. That we have learned in our previous session. Now, we are going to find its parametric form. Okay, parametric form means to find the parametric form. So let's take that line OP. Makes an angle theta with the positive direction of the x-axis. Okay, so I repeat the statement, dear students. So take any point P on the circle and draw a line joining OP to the center such that it makes an angle theta with the positive direction of x-axis, as you see in the adjoining diagram. So our target in the parametric form is to express x and y in terms of r and theta. Okay. So now if we do this thing, so there is this small construction that we draw a perpendicular from P on the x-axis and let A be the foot of the perpendicular, as you see, dear students. Now in the right angle triangle POA, what we see? In the right angle triangle POA, so PA is perpendicular to, as we see, is that PA is perpendicular to x-axis, correct? Now what we can do here is that in the triangle, in the right angle triangle POA, so what we are going to get in the right angle triangle POA is that x equal to r cos theta. What is x? X is OA. So let me write elaborately. OA. So what is cos theta? Cos theta is equal to base by hypotenuse, that is OA, divided by OP, and sin theta is equal to, AP by OP. This implies what, dear students? What is OA? OA is nothing but x, that is the x coordinate of the point P. So that means x by r is equal to cos theta, and y by r is equal to sin theta. So from here what we get, dear students? X is equal to r cos theta and y is equal to r sin theta. So this x equal to r cos theta and y equal to r sin theta, satisfies the equation of the circle when theta is in between 0 to 2 pi, because theta can vary like this, no? So theta, it can be anyone from 0 to up to, it can go up to 360 degree. So here 0 less than equal to theta less than equal to 2 pi. So what we see, dear students? The coordinate of the point which was x comma y, okay, in the then it actually become P x is equal to r cos theta comma r sin theta. So this is the parametric point, and we can also say that the parametric equation of the circle is x equal to r cos theta and y equal to r sin theta. So there are two things. One thing is that the point P, r cos theta comma r sin theta, is a parametric point on the circle, and also x equal to r cos theta and y equal to r sin theta jointly representing the parametric equation of the circle x square plus y square equal to r square. Correct, dear students? So this is what is the parametric equation of a circle when we consider the center of the circle at the origin. Now, dear students, what we are going to do, we are going to extend it so that we are going to find the equation, parametric equation of the circle, when the center is not necessarily to be at the origin. So let's take, the center is at the, is at the point h comma k. So let me show you the diagram. Okay, if I show you the diagram, so it will be much more clear to you. So it is something like this, dear students. If you see in the left hand side, I draw the diagram here. Okay, and what we see here is that that the center C is at the point h comma k. Okay, now what we know about that equation of this circle, if the radius is r, that means Cp is r, and the moment we know Cp is equal to r, then what is the Cartesian coordinate equation for this circle? We know x minus h whole square plus y minus k whole square is equal to r square, isn't it? That is the equation of the circle with center at the point h comma k and radius r. Now what we are going to do is that, we take a point P, arbitrary point P with coordinate x comma y. Then you see, dear students, that from the center C, if we draw a perpendicular to the x-axis, and let me name it as A, and from the arbitrary point P, we draw a perpendicular to the x-axis and we name it as B. Then what is OA? OA is H, because coordinate of the center C is H comma K. Na? So we get OA is equal to H. We get OB is equal to X. Correct? We get CA is equal to K, because y coordinate of the point C is K, and we get PB is equal to y. PB is equal to y, because it is the y coordinate of the point P. Now from these two information, OA is equal to H and OB is equal to X, what we can get? We get AB is equal to X minus H. That gives AB is equal to X minus H, isn't it, dear students? And from CA is equal to K and PB equal to Y, we get PN is equal to, where N is the foot of the perpendicular drawn from the point C, that is the center of the circle, to the line segment PB. So Pn is equal to Y minus K. So AB is equal to X minus H means AB and Cn both are same, na? So Cn is equal to X minus H. Now that is interesting information. We get Cn is equal to X minus H and we get Pn is equal to Y minus K. Correct? Now from the triangle, if you consider the right angle triangle, CPN, okay, in the right angle triangle, from the right angle triangle, from the right angle triangle CPN, we get, what we are going to get is that, cos theta is equal to, theta is the angle, that when I should also define you that what is theta. It is clearly visible in the diagram as well. Theta is the angle made by the radius CP with the positive direction of x-axis. Okay, means as Cn is parallel to x-axis, so that means it makes with the angle Cn as well. So cos theta is equal to Cn by Cp, and sin theta is Pn by Cp. Correct? So this implies so cos theta is equal to Cn by Cp. So Cn is equal to Cp cos theta. What is Cn? Cn is nothing but X minus H divided by Cp. Cp is equal to R, that is equal to cos theta. And Pn is equal to Y minus K divided by Cp, that is equal to R, that is equal to sin theta. So from here, what we get is that X equal to H plus R cos theta and Y is equal to K plus R sin theta. Correct, dear students? And What you observe here is that, dear students, that like the previous case where 0 less than equal to theta less than equal to 2 pi, because theta can vary from 0 to 2 pi. So if you see that x minus h is equal to r cos theta and y minus k equal to r sin theta, or x equal to h plus r cos theta and y equal to k plus r sin theta, they represent the parametric equation of the circle. So this is nothing but the parametric equation of the circle. And what is the parametric point? Parametric point is h plus r cos theta and y plus r sin theta. That is the parametric equation of the circle. Parametric equation of the circle. You may think that, sir, why it is parametric? Here theta is the parameter, dear students. Apart from that, you see all are known to you. R is known to you, h and k is known to you, because you know the radius of the circle, that's why r is known to you. You know the coordinate of the center of the circle, that's why h and k is known to you. What is the parameter here? It's a theta. That means as you vary theta, you get different points on the circle, and hence by means of this parameter theta, we are able to find the equation of the circle, and eventually you can construct the circle also geometrically. So hence it is known as the parametric equation of the circle. And interestingly, dear students, is that the point what you see is that the point what we found as x comma y, that p with coordinate x comma y, now is the parametric point become h plus r cos theta comma k plus r sin theta. And one interesting point is that from this equation, whatever I have derived now, from there you can find the parametric equation of the circle when the center is at origin, just by applying h is equal to 0 and k equal to 0. If we apply h is equal to 0 and k is equal to 0, dear students, you will get exactly whatever we have done here, r cos theta comma r sin theta, right? So that's why I said in the beginning that for the ease of understanding, let us first consider a circle with the center at origin, and then generalize it to consider in case when the center is at any arbitrary point h comma k. I hope it is clearly understood, dear students. Now, what I'm going to discuss, the next point is that circle through 3 points. A circle passing through 3 points. Okay, and if you see in just in information, is that if you use any software where you can draw a circle, any software if you see where you can draw a circle, if you take any 2 points, okay, through 2 points you can have many circles you can construct. Okay, you take 2 arbitrary points and you can construct infinite number of circles passing through those 2 points. But if you take 3 points, you will see, dear students, that you are able to construct only a single circle. Okay, that you can experiment with any graphic software what you are exposed to. Okay, so now let's discuss this particular point here, and let me take it to the next page. That circle through 3 points. So, let us consider the 3 points the way we define that x1, y1, x2, y2, x3, y3, and 3 non-collinear. Obviously, they are on a circle, so there has to be no non-collinear. Okay, if they are non-collinear, an unique circle passing through the points, these 3 points is possible. Okay, so we are going to, I'll show you 2 different methods, to find the, to find the equation of the circle. Okay, so what I was telling, dear students, so is something like this. If 3 points A x1 comma y1, b x2 comma y2, and c x3 comma y3 are non-collinear, an unique circle passing through these 3 points is possible. And we are going to derive the equation of this, equation of that unique circle. And for that, we are going to use two methods. The first method I am going to explain you, dear students, now. The first method. Okay. So in the first method, what we are going to do, dear students, is that, so let me first, construct a circle. Okay. Then it will be clearly understandable. Suppose this is the circle. And we take 3 points. Suppose this is 1 point, this is 1 point, and this is 1 point. Suppose this is the point A having coordinates x1 comma y1. This is the point B having coordinates x2 comma y2. And this is the point C having coordinates x3 comma y3. Now, dear students, what I'm going to do is that, let's consider that center of the circle be C, okay, and having the coordinates alpha comma beta, okay. Now, what we can find it out from the circumcenter and circumradius. So we'll find that no, I need to do not C. So it is not good to take at C. So let's take this, the center is some other point. ABC already took. Now suppose let's take it as Q. Let's take Q be the center of the circle with coordinate alpha comma beta. Then what we can say that QA, QB, QC, and QA all are same, correct or not? So what is the value of QA? So QA is equal to QB is equal to QC, correct? So that implies QA square is equal to QB square equal to QC square. That implies QA square is equal to QB square is equal to QC square. Now, what is QA square? QA square, if you see, dear students, it is x1 minus alpha whole square plus y1 minus beta whole square. That is equal to x2 minus alpha whole square plus y2 minus beta whole square. That is equal to x3 minus alpha whole square plus y3 minus beta whole square, correct? So that is what we can find it out. And also, if we if we solve this, we find alpha beta, correct? And also we know the radius. So radius is equal to what? Radius is r is equal to square root of x1 minus alpha whole square plus y1 minus beta whole square. Okay. So what is r? R is equal to square root of x1 minus alpha whole square plus y1 minus beta whole square, correct? So, equation of the circle from here, what we are going to get is that x minus alpha whole square plus y minus beta whole square equal to r square. So from here, what we can find it out? See, equation of the circle, equation of the circle is now x minus alpha whole square plus y minus beta whole square is equal to r square. So dear students, one important point here is that alpha and beta is not known to you. We are assuming that coordinates of the center is alpha comma beta. And then we are able to find this relationship as you see here, dear students, that x1 minus alpha whole square plus y1 minus beta whole square is equal to x2 minus alpha whole square plus y2 minus beta whole square is equal to x3 minus alpha whole square plus y3 minus beta whole square. Correct? Now, as we able to get this thing, and the radius is equal to x1 minus alpha whole square plus y minus, so from there we can find the value of that alpha and beta. If we solve these three, then we can find that unknowns alpha and beta. And after that, the moment we find the value of alpha and beta, we can find the value of the radius, that is r. So from here, we find the value of alpha and beta. Let me write it down here. So find alpha and beta by solving this, relationship. After that, the moment you find alpha and beta, you know the value of x1 and y1. So you can find r. The moment you know the alpha and beta, that is the coordinates of the center and the radius r, it is very easy to find the equation of the circle, that is x minus alpha whole square plus y minus beta whole square equal to r square. This is the first method, dear students. Now the second method, what I am going to do, so first method we make use of that, what is called the, circum radius, and there is a circumcircle. So if I construct the circumcircle, so you'll be able to get it maybe. So something like this. So this is the, that whatever the circle, whatever the triangle I have drawn in the green color, ABC, that is the, that is the triangle, and the circle which is under consideration passing through the point ABC is called the circumcircle. So anyway, so this way we are able to do in the first method, we are able to find the unique way of finding the equation of the circle. Now I'm going to discuss about the second method, dear students. In the second method, what I'm going to do is that let us take the general equation of the circle. The second method. In the second method, let us consider what is the general equation of the circle. It is x square plus y square plus 2gx plus 2fy plus c is equal to 0, isn't it? That is the general equation of a circle. Okay, and we know, just for the sake of our repetition of our understanding, the center of this circle is at the point minus g comma minus f, and the radius of that circle is square root of g square plus f square minus c. Though it is not required in context to our discussion, but I'm just saying. Now, this circle, as you see, is passing through 3 points. It's okay, and this circle is passing through 3 points. First point is x1 comma y1, second one is x2 comma y2, and third one is called x3 comma y3. So then what you will get? So you will get x1 square plus y1 square plus 2gx1 plus 2fy1 plus c is equal to 0. In the similar manner, you will get x2 square plus y2 square plus 2g into x2 plus 2 into f into y2 plus c is equal to 0. And finally, x3 square plus y3 square plus 2gx3 plus 2f y3 plus c is equal to 0. So these are the three equations we get. And we have three unknowns, dear students. What are the three unknowns? G, f, and c. So it is very easy to find the equation of the circle. So from here, it is very easy to find the value of G, F, and C. Find G, F, and C. I repeat, there are three unknowns, G, F, and C, and we have three equations as you see. So three equations and three unknowns is very easy to solve the values of the three unknowns. And the moment you find the values of these three unknowns, you apply in this equation and you get the unique equation of the circle. Now the next point is that how you can solve these three equations. Easy method. One method is that whatever you have learned so far, from your previous classes knowledge, is that you take one equation. First equation you take express the value of C in terms of G and F, and that value of C in terms of G and F you apply in the other two equations. So you will get linear equations in two variables G and F. From there you find the value of G and F, and then after that you apply that value of G and F in any of this equation to find the value of C. But whatever I said in the last 30 seconds or so is that it is very easy to say, but it will take time to solve. Okay, it is not very easy that first you need to apply the value of C in terms of G and F, then you apply that value in the other two equations, then you solve the linear equations, then you find the value of G and F, and then you find the value of C eventually. But there are some efficient method using the determinants. Maybe you are not very well adversed with the determinants, dear students. So later when we will discuss about the solution to the system of linear equations, okay, there it will all come into the picture. But the best way of elimination of G, F, and C, okay, from this equation. So what we are going to get, that if we eliminate G, F, and C from all these equations, that is starting from the general equation of the starting from the general equation of the straight line, whatever we have assumed, this one and these three equations, then we can the best way of eliminating that G, F, and C is something like this, is that square root of slip of my tongue. So the determinants is that x square plus y square, then x, y, 1, then x1 square plus y1 square, x1 square plus y1 square, then x1, y1, 1, it is 1, x1, y1, 1, then x2 square plus y2 square, then x2, y2, 1, and then x3 square plus y3 square, then x3, y3, 1. This value has to be equal to 0. Okay, and this equation, what you see that in the form of determinant, is the equation of the circle passing through the points A, B, and C. That is the three given points with coordinate x1, y1, comma x2, y2, and x3, y3. So this is the required equation of the circle. This is the required equation of the circle. I hope things are very well understood. If you have any slightest doubt, never hesitate to let me know. And with this, I would like to conclude the class for today. Then in the next class, what we'll discuss about the concentric circles, and then the other relevant topics we will discuss, and also solve some numerical questions together. Meanwhile, dear students, you can start solving the questions what is available in that online test platform at KonarClasses.com. You can start appearing DPPs, one DPP per day, and things will be very fine over a period of time. So with this note, dear students, I would like to conclude the class now. Thank you very much.